Hi guys, welcome back to BGSS Science. For today, we're going to do something on pressure. And before we begin, I want you all to take a look at this person, Pascal, the father of pressure, the one who gave rise to this chapter, namely pressure. And of course, later on, this name Pascal will be very famous throughout your entire chapter, as you are going to write SI unit Pascal. Now, a little bit about Pascal. He's a physicist as well as a mathematician. One of his most famous work is over here, the Pascal triangle, as you all can see on the right of this side over here. So this is the Pascal triangle, and he's the one who came out with it. Of course, if you are more interested, please just head on to Wikipedia and Google his name, Blaise Pascal. Okay, so we'll start today. But before we start with pressure, let's take a look at this video. Now, if the video is, say, too soft, the link is below, so just check out the video, the link below.
It's number one priority. For this experiment, we're gonna need 2 balloons, 100 thumbtacks. So first we're gonna blow up the balloon.
Okay, I'm going to fast forward a bit, and we're going to continue here. So he's going to lie down a bed of nails, as you all will see in the video.
100 top pins. And we have to set them up like upright, you know what I mean? So all the sharp point is on the top. And now we kinda have to put them together on the same level, not too close, don't like jump them on each other. So check it out, this is like a nail bed. So now we need to blow up another balloon. And now we're gonna put this balloon on top of all this again, and check it out. I can apply a lot of pressure, look at it, and it doesn't pop, a lot of it.
So under this circumstance, when I have a balloon, and let me use a different color, and I have, say, 100 nails below this balloon. Okay, the conclusion, the outcome is that it doesn't pop. Okay, from the video you all see that happening. Okay, now let's continue watching the video.
You see how much pressure I put? See, and it doesn't pop. I roll it on it, doesn't pop at all. So let's move all these ones and just leave just one once again. Alright, you see, just one right here left, and I'm just gonna put it on top of it like that. You see it pop right away.
Okay, and from that video too, we see something else. We see that if you just have one balloon, right, and you only have one nail, just one nail, instead of 100 nails, now you have just one nail. This thing, it pops. So why is that so? And that has got to do with pressure, and that's what we're going to figure out today. And we are going to technical details into this phenomenon later on, but let's first look at what is pressure. Now, pressure is defined as the force per unit area. Okay, and the SI unit for pressure is therefore Pascal, because it's the one who came out with the idea of pressure, and it's symbolized with the alphabet PA, capital P, small a. Okay, so this definition, please memorize it, and observation made in video. So you might want to draw this diagram here into this box over here. If not, just leave it blank. Okay, but basically you realize that the balloon pops with one nail. And the second observation that you make is that the balloon doesn't pop with a bed of nails. Okay, now, so let's go into a deeper consideration of what's happening over here. When the school reopens, I'll show you another experiment that has got to do with this, and I want you all to probably give me a good prediction of what's happening and a good explanation as well. Okay, so let's go into the various aspects. To consider this phenomenon, we first have to consider the force. Now, what is the force on the balloon? Okay, so the force, as you've seen on the video, is the force of the guy's hand on the balloon.
Again, and check it out.
So he's pushing it with consistent amount of force. Okay, so let's just say that there's a push by the hand, and this push, let's call it a constant amount of force. Let's just label it as 5 Newton, 5 Newton. And of course, there's the weight of the balloon, right? So the force here is the force by the experimentalist's hand plus the weight of the balloon. So this is the force. Okay. Now, so the force in both cases are the same, and therefore you might want to consider this then. Number one, it's not the force that causes that pops the balloon. Okay, so it's not the force that actually pops the balloon. It's something else, and it has got to do with this topic, obviously. Okay, so the second part that we want to look at is the area. Okay, now in this case we are going to look at the area, and this is not just any normal area. I want you to write this down. This is actually referring to specifically, sorry for the ink. Let me choose another color. Okay. This is specifically talking about contact area, the area in which it has contact with another body. Okay, so we are not talking about the area of the balloon. We are not talking about this area. No, that's not what we are talking about. What we are talking about is the area that is in contact. Now, in this case, the area that is in contact is this area only. Okay, so we call this the contact area. And how about for this? Then therefore the contact area is somewhere here. Okay. Now, so there's a difference now. So the second conclusion that we can draw from here, but first let me write down the point here. You realize that the area is larger for bit of nails. Yes, bit of nail is the scenario A, right? And this is scenario B. Okay, so you realize that this has a greater contact area, right? Compared to this. Okay, so area is smaller for single pin on nail. Okay. Now, so you realize that so the area has a difference and actually has a different outcome. So maybe, just maybe, right? It might be the area that pops the balloon. Now, this is not entirely true, and therefore we come out with the third thing that we want to consider, and that is pressure. Okay, now, so let me draw the two diagrams here. I have the scenario A balloon, in which I have a lot of nails underneath it, and I have the second scenario where I have just one nail underneath it. Okay, and then we say that this is A is small, right? And we say that this is A is big, right? Now, the idea of pressure is this. Pressure, as per the definition, okay, is force per unit area, and you'll learn it in Sec 2 also. So it's F over A. Now, if we call this scenario 1, and we call this scenario 2, okay, and I'm going to use different color. So maybe I'll use red for scenario 2. Okay, so let's do for scenario 1 first. Let's start to give it value. Okay, let's call this maybe 10 cm square, or 10 meter square, sorry, and let's call this 1 meter square, and let's call this 5 Newton. The force that we are considering is the force by the hand and the weight of the balloon. So the force is the same throughout. Okay, now for scenario 1, the pressure will then therefore be 5 over 10, which is 0.5 Pascal. Now for scenario 2, the pressure will be 5 over 1, which is 5 Pascal. That's about 10 times difference, right? Now, in other words, the third conclusion can be drawn. The pressure for the two scenarios are different. Now, please pause the video if you need time to copy down what I wrote, okay? Now, so the pressure for the two scenarios are different, and that is actually the reason why one pops and why the other doesn't, okay? And with this, we kind of start to understand the idea of pressure. Now, pressure, especially when you talk about area, right, is actually the contact area. It's not the area of the balloon, it's the contact area. So just this and this, okay? Now, let's properly mathematically define pressure, and therefore we have this formula: P equals to F over A, where P is referring to pressure with the SI unit Pascal, F is referring to the force, and this has a SI unit Newton, and of course area refers to the contact area, okay, the area in which the object is in contact with another object. Okay, now contact area, this one has SI unit either cm square or meter square, okay, but please always convert to meter square unless question says otherwise. Now, to know how to convert to meter square, please look at my previous notes, or you can ask me when school reopens in this mathematics question. So if you are not sure, you can let me know, okay, but I'm not going to explain this video. Okay, so this is the idea of pressure. Alright, so depending on the area, once again, depending on the area, really, even though we have the same amount of force, this is 5 Newton, and the second scenario is also 5 Newton, the pressure actually differs. One is 0.5 and one is 5. Okay, so now let's do some question. Okay, you might want to try on your own, so you might want to pause the video here, okay, but I'm going to go through the answer now. So I hope you pause, do the question first, and then play the video again so that you can go through with me the answer. Alright, first thing first, the weight of the block. So this is from chapter 4, W equals to mg, if you want to recall. I'm sorry. Before you do that, right, you need to consider these few things. Okay, so density, and this will actually give the volume. So density equals to mass. Density equals to mass over volume. So mass equals to density times volume, which is equals to 2.5 times 10 times 6 times 2. Okay, you get your calculator, you get 5 times 10. You get 300. Now this is in gram, because this is in gram. Okay, which 300 will therefore be 0.3 kg. So the mass is 0.3. This is the mass. Now using the formula W equals mg, therefore W equals to 0.3 times 10, which is actually 3 Newton. So this box weighs 3 Newton. Okay. Now remember that the contact area has to always be in meter square. So this is 10 by 6 by 2. Now, but these are in cm, so let's convert it to meter. Okay, so this becomes 0.1 meter. This becomes 0.02 meter, 0.06 meter. Okay, and therefore the maximum possible pressure, that means you want to have the highest pressure. So remember this experiment. At which scenario has the highest pressure? Scenario 1 or scenario 2? Okay, it's scenario 2, and that's because the contact area is small. So in which part of this cuboid will the area be small? Is it this part, or this part? Okay, that's what you have to consider when you do this question. So let's call it 1, 2, 3. Okay, so maximum possible pressure will be contact area 2. Okay, and therefore P equals to F over A, which is equals to force, which is the 3 Newton, over the area, which is area number 2. To get area number 2, you just take 0.02 times 0.06. Okay, press your calculator, you should get answer. Okay, so let's do that. 0.02 times 0.06, and then you have 3 divided by 0.0012. You get 2500 Pascal. Alright. For the minimum possible pressure, so you want the least pressure. So for the least pressure is back to scenario 1. You realize that will be the greatest area. So for minimum, you want the contact area to be the greatest, and in this case, the one with the greatest contact area is contact area number 3. So that's contact area number 3. So once again, P equals to F over A, which is equals to 3 over contact area number 3 will be 0.1 times 0.06. So we have, which is equals to, so we can do this 0.1 times 0.06. We have 3 divided by 0.006. Okay, you get 500 Pascal. And then you can draw one conclusion. Same object, placed on different side. It actually gives rise to different pressure. Okay, in fact 5 times difference. Okay, so for B the pressure is 2500 Pascal. For C the pressure is 500 Pascal, but the fact remains, the object is the same object. Okay, now for question 2, A, B and C, you all can do it as homework, and I'll show you all the answer at the end of this video. Right, so if you want to answer, either click the link below. There's this section called answers to question 2, or just head on to the last few minutes of the video. Okay, now I want to further analyze pressure. So let's think about a car. Okay, so I have a car, a very simple car. Okay, and the car has 4 wheels, right? So 2 in front and the 1 behind, let me draw it in red. Okay, so it has 4 wheels, right? Now if we turn over the car and we look at it in another manner, it will look something like this. So let me redraw it. Then we have 1 wheel here, 2 wheel here, 3 wheel here, 4 wheel here. So these are all wheels, right? Now then let's talk about what a wheel does. Alright, so first thing first, we need to consider the force. Okay, so always consider 3 things: the force, the area, and therefore the pressure. Now what is the force acting on the wheel this time? Okay, if you are not pushing the car down, no one is pushing the car down, the force is simply the weight of the car, right? And the part that is in contact area with the rest of the road is the wheels, right? So the 4 wheels, and therefore the pressure will therefore be the weight of car over the 4 wheels. Okay, now comes the question. Okay, and the question, can you write it here? Will the pressure be the same on 1 wheel if the car is cut into 4? Okay, that's what we're going to answer over here. Okay, so if I cut a car into 4, okay, so let me cut it with green. Okay, I cut it, and let me just consider just one part. Now, will I get the same pressure? Okay, now we'll do a numerical calculation later, but the answer is actually yes, because the area is divided by 4, but the weight is also being divided by 4. Okay, so let's do an example. Okay, so suppose the force, right, of the car, right, let's say the car is 250 kg, that's about the weight of the car will therefore be 2500 Newton. Okay, now the area, okay, let's say one wheel has an area of 1 meter square. Therefore the pressure, right, will be 2500 over 4, and that will give us 625 Pascal. Okay, then we do the working for the second part where we cut the car into 4. Now consider this, when we cut the car into 4, right, okay, so this is the car with the wheels, and we are going to cut it into 4, and we are just only going to consider this part. Now do realize something, okay, the force now equals to 2500 divided by 4, okay, because you are going to cut the, it's like cutting a pear into 4 equal parts, right? If the pear is 1 kg at first, now you cut it into 4 equal parts, each part now is 0.25 kg. So it's the same. I have a car, 2500 Newton, I cut it into 4, obviously the weight is going to be divided by 4. Okay, the force therefore becomes 625 Newton. The area, which is just one wheel, is just 1 meter square. Now please note that this is 4 wheels. Alright, and therefore the pressure is 625 over 1, which gives you 625 Pascal. And you realize that it's the same. Okay, so the pressure is being distributed equally when there's 4 wheels, okay, as per 1 wheel. Alright, we have come to the part, the end of this chapter. The rest are not exactly in your syllabus, but you'll learn it again when you're in Sec 5, so I thought I might as well teach you here. Okay, so please don't end the video yet, even though I made that statement, and please remember to go to the end of the video to look at your answer for question 2. Okay, so let's continue on here. Other than the pressure that we just learned, right, there's a modern application of pressure, and we call it the hydraulic system. Okay, hydraulic system work by using actually pressure, and the idea is this. First thing first, liquids are incompressible. Now some of y'all won't understand what is hydraulic pressure yet. Don't worry, I'll show you a video in a while. In fact, the video is in the link below, so at this point you may want to pause the video, click the link below, watch the video, and then come back to these notes, okay, to have an idea of what hydraulic pressure, hydraulic system is talking about. Hydraulic system here, right? Okay, so basically the idea is that you want to use a small force, okay, to lift a heavy load. Okay, and that is awesome, right? It's that you use a little force to maybe move a car, you use a little force to maybe lift up yourself. So if you all haven't noticed yet, okay, if you are on a chair, sorry, the chair doesn't really, the chair looks something like this, right? This is the office kind of chair, and then there's something over here, and then you are seated here. Alright, you're seated here, okay, and you want to move up, right? What do? You click this thing, right? And then you realize something, with the small amount of force that you use on your hand, okay, small force by hand, you actually lift yourself up, okay, and you realize that you might be heavy, so even though the force is small, you're still able to lift yourself up, and that's amazing. Using the idea is this, that using a small amount of force to lift something heavy. This was why hydraulic system was created in the first place. Okay, so let's look at this in detail and try out some questions. Okay, now if you have watched a video, then you should kind of understand what's happening. Okay, so you might want to ignore this part of the diagram. Okay, so let's just look at this. Now when I push this down, I'm actually able to push the car up. Okay, and this is still pressure, it's still pressure. Okay, and in fact the pressure here and the pressure here, they are the same. Okay, so the pressure is being transmitted from one point to another. In other words, the pressure caused by your hand and the pressure that's pushing the car up is the same. So pressure by hand equals to pressure by the car. If you want to push the car up, you need a certain pressure, okay, and they are the same. And therefore you have F hand, let's call it F1, okay, and we call this 2, okay. So we're going to use black and red, so we have F1 over A1 because that's T1, and we have T2 which is F2 over A2, and they are actually equivalent. So we have F1 over A1 equals to F2 over A2. Okay, so this is the equation that we want to look at, and this is so because we have T1 equals to T2. Okay, so the pressure exerted is being transmitted is equals to the pressure transmitted. Okay, so how much you exert here, the pressure you exert here is the same as the pressure here. Okay, of course A1, A2 are just the contact area between the liquid and the piston. Alright, now we can actually end off here because you might want to try this question, and I think in order to try this question you need to know this piston, right, is actually circular, and the area of a circle, right, equals to pi r squared. Okay, this is diameter. Okay, so remember that r equals to 0.25. Remember to divide by 2, so r equals to 2.5. Okay, with this you should be able to do, I'll show the answer at the end of the video also. Just click the link below on the timing and you'll be able to get the answer for hydraulic system question. Okay, so that'll be all, and I'll end my video here. I hope you all will be able to understand what is pressure. If you want to practice, do practice your TYS question on pressure. It should be fairly simple if you understand what this video is about. So I'll end off here, and I hope you all enjoyed this video. Thank you so much. Bye bye.